Hi, in this video I'm going to give you the rest of the solution to the defaulting customer assignment part 1. So in your course packet you have these univariate descriptive class exercises, and then we have this defaulting customer problem. There's a video link for parts A and B that show you how to read in the data. So you should watch that video if you've not already done so. Of course, if you've already brought the data set in and having any problems, then don't bother watching the video. So the data set that I read in, I saved earlier, and so it's really important that you save it after you've read it in, and I called it default.sav. So the .sav indicates that this is an SPSS file. So it comes up in the top of my list since I've just been using it. So I'm going to hit OK, and instead of having to go through all those steps of using read text data and then typing in the value labels, what you're going to see is that all that work that I did last time is saved. All right, let's go back to the problem. So consider age, generate a histogram and a frequency distribution. All right, so let's go generate a histogram and a frequency distribution. Now, to get the histogram, we could go to graphs, but we could also get it while we generate the frequency distribution. So let's do as few clicks as possible. We'll go up to descriptive statistics and frequency. So recall that this is how we get a frequency distribution. And we have this box where we can copy variables in. I'm going to bring age in. Now, to get the histogram, we can go over to charts here, and you'll see that one of the options is a histogram. So let's select that. Go hit OK, and it takes SPSS a second. So we get our frequency distribution and the histogram. I think the histogram tells the story pretty clearly, although we can go back and look at the frequency distribution to confirm some things that we see here. So recall that these are adults. These are adults joining the health club, yet we have this giant spike of 0-year-olds. We have another spike of 2-year-olds and looks like 3-year-olds. So this looks like dirty data. The other thing that really bothers me is this spike of 99s. Now, if we had a spike of 98s and 97s and 96s, maybe I would believe it. But the fact that there's this big gap between a 79-year-old and a 99-year-old means that these don't smell right. And we can go look at the frequency distribution. Sure enough, there's 26 99-year-olds. If we go to the top, we have all these cases that don't make much sense. So these are probably cases that where the person refused to give an age, is my guess. That's just a guess. In which case you have somebody who's not 99 saying there's 99, or at least they're typing in 99 to get to the next screen. That's just noise, and we want to get it out of the data set. Okay, so I think we've done part C. Part D says set all cases that you consider to be nonsensical to missing. So yeah, we need to so we're going to use transform recode to do this. Well, I'm not quite sure how old you have to be to join Bally's. I suspect that 2 is too young, 4 is probably too young. Maybe I could see a 16-year-old or even a 15-year-old joining. So, there's no right cutoff, and it's probably not going to make a big difference if we cut it at 15 or 16. Perhaps even 14 is a reasonable value. Let's just cut it at 16 for now. So we want to set these equal to missing. To do that, I'm going to go up to transform, and we're going to recode into a different variable. You don't want to overwrite your original variable, usually, because sometimes you make a mistake and you want to go back. So it's probably quicker to make a new variable. Now I'm going to make a variable called, so to use this transform recode into a different variable box, we're going to copy age in. Then I need to give a new variable name. Let's call it age2. good to give yourself a meaningful label. So this is age without extreme values, or outliers. Why don't we just call them outliers? Now, what I forgot to do the first time I ever used this menu was to hit change, and it won't work unless you hit change, and that brings age 2 into this box. The next thing we have to do is go down to these old and new values, and I'm going to specify a range. So all values, I think I said 60 through 80-ish is fine. What we're going to do is just copy, and then you're going to hit add. All other values we're going to set to system missing. Go hit add and go hit continue. Go hit OK. And so in this data set, what you'll now see is that there's an age 2 variable that equals age whenever age is a reasonable thing, but whenever it's a 0, whenever age was 0, age 2 is now missing. It's a good idea to save this, because this is I just made an important change. So Command S or Control S on a PC. I'm going to go run some descriptives on this, and if we run some descriptives, what you'll see is, let's bring age in and age 2. So we'll run both age and age 2 in descriptives. You'll see that we've just eliminated about 2,000 cases. So age 2, or age without outliers, has 22, 8 something or other. Age has 24. So we got rid of a lot of the dirt. So let's see, have I done everything I asked for? Yes, I have. All right, find the skewness of age using descriptives or explore. What does it tell you? So first off, let's go make another histogram. And let's see, histogram. And I'm going to bring age 2 in now. Go hit OK, and you'll see the histogram is much cleaned up, and it's a bit right skewed. We've got a long right tail. And for part E, I said go find the skewness. So I'll go back to descriptives, and we can go into options to get skewness. So I'll go check off skewness. We don't need age anymore, so just do this on age 2. And we get a value of skewness of 1.206. I reported 1.233 in the answer. That's okay. I probably had made a different assumption about age. They're equal to 2 decimal places. That's pretty good. They both tell us that we have a right skew distribution. So you can either look at the histogram, or sometimes it's easier to look at the skewness statistic. So those two together tell us about the skewness. Part D, F. Let's go into part F. Generate a histogram of down payment and describe its shape. So let's see, to make a histogram, we'll go into Legacy Dialogues, under Graphs, and then Histogram. Let's get age out, and we're going to put down payment in. So right here's down payment. Go hit OK. And what we see is a very right skew distribution. The vast majority of people are in this one bar, and then presumably the values all go out to about 10,000 or so, otherwise the graph wouldn't go out that far. Part G, based on the shape of down payment, do you expect the mean to be greater than, less than, or equal to the median? Well, since we have a right skewed distribution with outliers, the mean gets pulled out by the outliers, the median does not. So if we wanted to see that, the way we could do so, see those statistics, would be to go into descriptives and then go into explore. Explore will give us medians. So where are we? We need down payment. I'm going to turn off the plots. Actually, let's just get statistics, so turn off the plots that way. And sure enough, we see that the mean is $199, the median is just 100. So the mean is greater. Why? Because of that right tail that's pulling the mean out. Find the mean, the median, and the 5% trim mean. Oh, I guess we just did part H as well. You'll see that the trimmed mean is somewhere in between the mean and the median, so it's 146. And that makes sense. So remember, the trimmed mean is kind of a halfway. It's a halfway house between the mean and the median. So the 0% trimmed mean is when you trim nothing. Therefore, you get the plain old mean. If you trim almost half of your data from each tail, you're left with one value in the middle. That one value is the median. So that's why we usually expect the median to be somewhere between those two. Part I, generate a frequency distribution of down payment and sort the values in descending order of counts. So let's try that. Analyze descriptives frequencies. So we need a frequency distribution. Let's get age out, and we're going to stick, where is it? Down payment in.